Let me thank Joe for giving me an opportunity to introduce you all with the NLOT. I think it's a nice time to initiate the discussion on this because um, the telescope is raw, so you can you know mold it the way you want. So basically, when I say the title, I just mean it: ambition, capability, and choices. It's your choice that is going to be there in the NLOT. So I think we have to work for that. So as Yogesh has already given you an overview of some of the telescopes. So these are the 1 meter telescopes that we have. These are 2 meter class. This is the HCT, then Giravali and BBT. BBT is the one which we made in country for the first time. Unfortunately, all other telescopes we just thought of buying it, but now we are in a process of building telescopes here. Okay, so this is the 2.5 meter in Mount Abu, 3.6 meter, and possibly we will have a 3.7 meter UHCT sooner. This will be again a segmented mirror telescope. I'm not going to talk much on it because we have started working on it and we are deriving the parameters for it. But this will be having a 7 segmented telescope, and it's partially for science as well as it's a pathfinder for NLOT. So many of the technologies that we require for NLOT will be tested here. Basically, the co-phasing of the segments. And this telescope, we are planning to make it lighter so that we can use it for primarily for time domain astronomy so that you can maneuver the telescope much easier. So that's the basic idea, but we have just started working on it. Okay, so if you look at the landscape of bigger telescopes in the world, you have 8 meter class telescope, then you have a couple of 10 meter and then 10.4, which is the biggest one in La Palma. And then we are going to have, these giants basically. ELT will definitely come. Others, if it comes, it would be a very good scenario. But then you can see that there is a big jump from 10 meter to 25 meter class telescopes. So sometime in August, so we have been trying to propose for a bigger telescope, a 10 meter class telescope. I think the first proposal was put into 2006, and we were not successful in getting through for the funding. But in August, DST asked us to submit a proposal with 8 meter to 13 meter aperture telescopes. Basically, the numbers defined by the number of rings. These segments will be the identical to that which will be used for the TMT. So 1.44 meter in the diagonal and 1.224 meter in the flat surface. That is why when you combine them, you get weird numbers like 8.7, 11.2, or 13.7. So, for example, if you multiply the 8 plus 9 multiplied by 1.24, you get the diameter of the telescope. We gave the timeline as well as the cost, the baseline cost for these apertures, and EST said you go with 13.7 meter. I mean, they asked us to put a DPR. DPR in somewhere in around October, we started preparing. In fact, they did not ask us to submit the DPR. We just started to prepare a DPR, anticipating that DST might ask us. And in January, they did. They asked us for a initial preliminary DPR, and we submitted for a 13.7. Oh, detailed project report, basically to give idea about a very preliminary design of the telescope and the way we are going to execute the project, which has all the budgetary requirements as well as the timeline and the kind of components that we are going to use, who is going to make these components, etc. The confidence to build a bigger telescope has primarily came from our involvement in the TMT. And we have a facility very close from here. It's called ITOF, India TMT Optical Fabrication Facility. And there we have facilities to basically polish, figure the mirror segments, and then hex it. You get a roundel, you polish it, and then you hex cut it so that you can make the hexagons. So this and other, technological aspects like the SSA, this is called the support segment assembly. This support the segment. So every segment will be supported by this SSAs, and there are about 500 SSAs which will be contributed or built by India as a in-kind contribution to the TMT. And these are basically the head sensors. So each segment has to be kept in phase, and that is done with this head sensor. So these are some of the components that we are contributing to TMT, which has given us the confidence in the fact that we can build our own big telescope using the segmentation. Apart from this, the entire observatory control software is also being developed in India. So often you might have seen this picture where you have all the telescopes and the future ones, and I have quietly put our 13.7 meter also here. So in the big telescope ecosystem, you will have an LOT which will be like the biggest one in the northern hemisphere. That you have to keep in mind. So ELT, which is going to come, is in the southern hemisphere. So your NLOT will be the biggest in the northern hemisphere. These are some of the specs that we have come up with. So when we were going for a DPR, we wanted to have the telescope design. We gave a very, first level parameters to the designers to come up with various designs. So the primary aperture is 13.7 meter, 90 segments, each one is 1.35 meters square. You multiply it, you get the exact collecting area of the telescope. Then, as I said, the segment size is 1.44 meter, and the operating wavelength we have chosen from 0.3 to 25 micron. Of course, this has huge implication on the telescope design as well as the, especially the coating of the segments. The limit, it's very crude value, but it's somewhere around 27 magnitude for SNR of 5 with 1 R exposure, and spectroscopic limitations is somewhere around 24 magnitude. We are planning to have a primary Cassegrain Nasmith, 2 Nasmiths, one with Seeing Limited and another with AO-Fed. You people might be interested in that, and a fold Cassegrain. So this we haven't decided on it. Fold Cassegrain is when you have instruments on the elevation ring, basically. So you can put several of lightweight instruments there. First light instruments, there was some community inputs, but we haven't finalized on. There are some new features which have been explored. For example, you can have a deployable secondary or a tertiary mirror. So tertiary can deploy out of the way of the beam, and you can use the Cassegrain focus as well. So in one night, you will have all the ports accessible to the observers. So this project timeline, we are envisaging that it will be at around 12 years. The budget is about 2,500 is what is allocated for the NLOT, and location is Leh. The median seeing is about 0.94 arc second, and the humidity is very low. As Yogesh was saying, that in most of the places we have huge problem with the humidity, so this is very low. And the atmospheric extinction and sky brightness are as good as any other observatories. The advantage of the Handley is that, if you go to the mid-infrared and beyond, the transparency is quite high. In fact, it is second to the Jasnetor, which of course is the best site. It's better than even the Monarchia because of the height. We also explored the bluer end, the 0.3, because that is also a very interesting region to explore, and we found that Handley site is much better in getting the 0.3 where you have the atmospheric cutoff. So this is the mountain where we have the Handley site. This is a zoomed in picture of the same mountain, and the peak we had reserved for NLOT right from the beginning. So this is the HCT. The new HCT will be somewhere here. We are still finalizing the location. So to produce the DPR, we made certain groups. Manoj and Smita led the overall science group, and we divided the overall science themes into 8, basically the 8 themes, and Anandamayi and Joe were leading the exoplanet theme. So they prepared a very nice document where what all things you can do for exoplanet science by getting input from the community. If they haven't contacted you, it's not their fault, it is our fault, because we gave them very, very less time to react to our call. The main idea is to keep the science to contemporary, synergy with the national and international facilities, and then always keep something for the discovery, because this is going to have huge discovery potential as the time progresses. The summary of the requirements that is given by Joe, I just listed them out. Maybe you can take a look at that later on, but basically what the team has given is emphasis on direct imaging and spectroscopy of exoplanet, especially on the high contrast imaging, then spin orbit alignment measurements, high dispersion spectroscopy for exoplanet atmosphere and biosignatures. And these are basically the requirements that were given to us to basically carry out these studies. And this is the plot which Joe has given, basically taken from this paper, but what he has added is the inner working angle for EMT, and then for 13.7 and 3.6. I guess the habitable zone will be populated with much more in the coming future. Then the microlensing host star characterization and the precision radial velocity. So these were some of the science cases that were come up with the with the call that we made. So these are basically the requirements that came from all other science cases, and you can see that exoplanet actually is crucial in getting some of these vital parameters, especially the adaptive optics capability, which should be the exoplanet science is a key factor in driving for adaptive optics capability. Here also you can see there are high contrast imaging and the instrument stability, which is something that you require for precision RVs. So we have come up with a very, very preliminary design for the NLOT. I mean, it's just a sketch that I made, so pardon me for its not as professional it is. but what this tells you is that you will have a primary focus with almost 1 degree. I mean, this is just to give an option for the future, to explore if they want to put, or you can even have a 1 meter right away, 1 degree field of view right away. Then one Nasmith platform for seeing limited instruments, one for the AO fed, and the Cassegrain focus with a 10 arc-minute FOV. This is basically, we wanted it for carrying out spectropolarimeter. So you can see the scale. So it will be a huge, structure. These are some of the instruments that we have come up with, but don't give attention to it because for any instrument suite, we require a rank list, not a wish list. We have to rank the instruments based on the science requirement. So that is the reason why this community, a collection of exoplanet community is excellent, because you can maybe brainstorm it to get what are the first light instruments that you require from day one, which instruments can wait for phase 2, and which instrument would enable the highest, citation impact science, something which as a community for all the science cases we have to come. And some of the typical contenders I have listed out here, but it should have a heritage within the country. That is very important, because at the end of the day, we have to develop it, or it should have a collaboration, should look for collaboration through which we can get a very good high impact instrument for the facility. Adaptive optics strategy, we have to see what fraction of the key science require AO. Is ground layer AO sufficient, or extreme AO? Come up with justification. And do we prioritize what type of observation? That is also key, because as Yogesh said that, modes of observations are key, because then only you can, design your observation strategy. Survey versus targeted operation model, and synergy with the existing and the future Indian and international facilities. Of course, we should have future proofing as well, because the way the technology is changing, the way the AI that is impacting us, I think we should have a future proofing option for this telescope, and some of the hard trade-off questions as well. So let us build NLOT together, keep the ambition, capability, and choices intact. Now let me provoke the community with certain questions. In 2038, what exoplanet discovery would make India globally indispensable? I think, are we aiming to follow, compete, or lead? What can only a 30-meter telescope uniquely do in exoplanet research? Of course, we have to keep, the global scenarios in our mind, because when this telescope comes up, one of the ELTs will be working. So where are we in the ecosystem of these ELTs and the space missions? And what are the top 5 compelling science questions that require a 13-meter facility? Which science cases are impossible or severely limited because of the Indian or international access? Some of them has been already listed by Yogesh. What can NLOT be globally competitive, not merely complementary? And what discoveries are expected? This is important. I think we should have some idea or a sense, so that we can also have plan our instruments for the 13-meter and rank science by impact versus uniqueness. With that, I just leave the floor.
Thanks, Mahesh, for the excellent overview of NLOT project. So now time for questions.
Yeah, so even though this is what the the operating wavelength is going to be not the optimized one. The idea for pushing it is because the humidity level is so low that we can push it to 25 micron, which will be good for maybe star formation guys.
The 25 micron, it's not necessarily the humidity, right? It's the background itself.
That is also true. Yes. So the telescope design itself will be crucial for it, even your secondary, everything. So we are exploring. I mean, this is just a number that we have kept.
I won't take too much time. My others are also waiting. But yeah, because of the thermal background, it
I agree.
kills
I
it.
agree with. Yeah. But 5 for sure.
Five definitely.
Yeah.
Yeah. So just one quick follow-up question. You mentioned about the site. So how does it compare with some of the Chilean sites?
Okay. So Jasnetor, as I said, is the best. But compare with other sites, it is
Maranal or Charopanchan?
it is comparable or better in the sense of infrared.
Thank you.
This is really good one. So when you were showing the slides before the imaging one, I was messaging Liton that, hey, it would be good to have a chronographic instrument just to have it. And then the next slide you showed that there's a it's so some of the signs, I think we discussed this in the last few days, perhaps you missed it because you weren't here. In the next 10 years, you would have several radial velocity candidate planets. Even already we have right now, maybe tens of them. Joe showed a plot of Corey Beard paper that's Surat students that we published last year. And that particular figure has almost all the currently known nearby planets. Probably mostly all of them are non-transiting planets. And those are going to be the most important targets in the solar neighborhood. Considering if this telescope is going to see the first light in the 2030s, late 2030s, I think it can be operable even before HWO is going to fly up. And so if you are going to make some of these compelling science questions, fundamental discoveries, I think this is your killer science. I would say that to observe almost all of the nearby non-transiting planets around M dwarfs, depending on how much time can be allocated to the exoplanet science. And so that this is a super nice development, I would say.
So I would say that, as a community, since you have already gathered for a meeting and for discussing, it will be good if you come up with a document where, these things can be captured. And as a community, if you can give, that'll be very good, because
I messaged Liton about some ideas. So
Maheshwar, this was a nice overview of this ambitious program. So I was just wondering, is there any plan for demonstrating the working of the segmented technology from India with a smaller?
that's exactly what the 3.7 meter that we are talking about.
Okay,
But I didn't say much because see, the thing is, when you go to the smaller and smaller, your radius of curvature is going to be, so you have a big curvature on the segment, right? So your the polishing, the hexing, all these equipments have to be modified. You cannot use it for all the segments. So the initial idea was the TMT figuring polishing equipment can be used directly for all of the telescopes. So that's not the case. So we have to modify things a little bit. But the idea is first you get the 3.7 meter, get all the know-how of the segment facing, basically, co-facing and co-focus. And then, so that knowledge will be always better.
That's a great idea.
So you mentioned that the observatory control system is also being made in-house. So is there a
Pardon? Can you just repeat?
you mentioned that the telescope control system is also being made in-house. So is there a plan to make it like a web application so that it can also be operated remotely?
Yes, it is. It can be implemented. Yeah, very well.
Because you said that
Yeah.
these observations are very
Yes. Absolutely. So the Himalayan Chandra telescope is basically remote controlled. So it's observed from Bangalore basically, right? But then yeah, I mean, we have to think about all. For example, the observer need not even go to the observatory and then can participate in the observations. Such things can be done.
For even like you said, for AI compatibility, if it is remotely observable, can the proposal site, proposal sorting out and planning the observation, that can be done automatically using a robotic mode? For example, if there are multiple proposals that have come for the NLOT, an algorithm can select what time to allot to which
Oh
proposal,
yeah,
so
yes,
it
yes,
can
yes.
automatically do that.
Yes, yeah.
Okay, so any more questions? Oh, Madhu? Yeah.
And does Chinese make their 14 meter, which is always yeah.
Okay. So let's thank again Maheshwar for the great talk and introducing us NLOT.